So let us see this next concept, combination of translational motion as well as rotational motion. See here, consider this is a rigid body, disc, sea, sphere, solid sphere, anything. So it is just moving in a straight line. Okay, it is not rotating. So it's just if it is a disc is moving like this. Clear now? Then it is having which type of motion? Translational motion. No? What is its velocity of center of mass? VCM. So center of mass is just moving like this. For example, consider this is a rigid body. That's it. Clear now? Then you take another same rigid body. If it is rotating about this axis, are you able to understand? With an angular velocity of omega. It means, for example, if this is the rigid body, just it is rotating like this. Okay, about the same axis. Velocity of center of mass is not there. Velocity of center of mass is 0 in this condition. So in this condition, this is only translational motion. So angular velocity will be 0. It is not rotating. Okay. This is what kind of motion? This is pure rotation. Pure rotation means what? Velocity of center of mass will be 0. Understood now? Angular velocity is 0. Velocity of center of mass is 0. Now if I combine both of them, it means that if you add these two motions, then it is a combination of translational motion as well as rotational motion. Are you able to understand? This rigid body is rotating also, and similarly it is moving in a straight line also. For example, you should have seen tires of a car, tires of a wheel, tires of a bike. Tire is moving forward, no? Tire munduku veltundi, anduke bike kuda munduku veltundi. Similarly, it is rotating also, no? Are you able to understand? That is an example of combination of translational motion as well as rotational motion. Are you able to understand? So it is rotating also, it is moving forward also. It means like how, for example, if this is the body, it is rotating also, similarly it is moving forward also, like this. Rotate kuda avutundi, alage mundariki kuda veltundi. Both are happening here. Are you able to understand? Okay, now see. Now if you see this rotating body, which is rotating with an angular velocity of omega, then it is rotating in this direction. Then if you take this point, let us call this point as point number 1. If you take this point, the topmost point, it will have a particular tangential speed. It rotate avutundi. This point, topmost point, it will have some tangential speed. And what is the formula for tangential speed? Okay, tangential speed is equals to total radius of the disk is how much? R. So therefore this point is also present at a distance of R only, no? So tangential speed will be how much? Omega into R. Clear? No? This point will have a tangential speed of omega into R. Okay. Now what about this point? Let us call this as point number 2. This point also have tangential speed, but it will be in this direction. No? So tangential speed of this point will be how much? It is also omega into R only. Are you able to understand? Because radius of this point is also R only. No? And total angular velocity of the rigid body is how much? Omega into R. But here velocity will be in this direction, here velocity is in this direction. Clear now? Similarly, if you take this third point, point number 3, then this point will have tangential speed in which direction? It will have tangential speed in this direction. Are you able to understand? So how much this one? So this is Vt3. Again it is omega into R. Are you able to understand? Similarly, if you take this point will have tangential speed in which direction? Let us call it as Vt4. So this is again equal to omega into R. Okay. So when a wheel is rolling like this, rotating like this, then these are the respective directions of tangential speeds. No? Are you able to understand? Okay. Now if you go to translational motion, center of mass velocity is how much? VCM. It means total body, it is moving like this. Okay. Now if you take this topmost point, again let us call it as point number 1, then this point also will it have some velocity or not? Our point kuda velocity untunda undadu? Velocity will be definitely there, no? How much velocity? Same velocity. Center of mass kanta velocity untundo, our point kudanu ante velocity untundi. So this is also having a velocity of VCM. Are you able to understand? Then what about this point, point number 2? Same, this is also having a velocity of VCM. All of them, they are moving like this, no? Then what about the point number 3? It will have how much speed? Again, in which direction? Same direction, velocity of center of mass. What about the point number 4? This also will have same speed number. Again, same speed of velocity of center of mass. Understood? No? అర్థమవుతుంది కదా? ఇప్పుడు ఈ పెన్నే రిజిడ్ బాడీ అనుకోండి, కన్సిడర్ దిస్ పెన్ యాజ్ రిజిడ్ బాడీ. ఇట్ ఈస్ మూవింగ్ లైక్ దిస్. దెన్ వెలాసిటీ ఆఫ్ ఎవ్రీ పాయింట్ విల్ హ్యావ్ సేమ్ స్పీడ్. నో, ప్రతి పాయింట్కి సేమ్ స్పీడ్. ఆర్ ఏబుల్ టు అండర్స్టాండ్? బట్ దట్ ఈస్ నాట్ ద కేస్ ఇన్ ద కేస్ ఆఫ్ రొటేషన్. స్పీడ్స్ మే బి సేమ్ when points are present at same distance, but directions are different. Are you able to understand? Now if you combine both of them, what I am combining translational motion as well as rotational motion. Renditni combine cheste, then this is how I can draw the diagram. Let us draw a bigger picture. Are you able to understand now? So let us call this point to be point number 1. I am adding both of them. Are you able to understand now? I am adding translation, I am adding rotation. Now if you take this first point, this point will have two velocities. No? One velocity because of translation, one velocity because of rotation. అర్థమవుతుంది కదా? ట్రాన్స్లేషన్ వల్ల ఏ వెలాసిటీ? v center of mass. Because of rotation, which velocity? Tangential velocity. Are you able to understand? So at the first point, body will have two velocities. And both of them, they are in the same direction in this condition. Are you able to understand? What is the first velocity? Velocity due to translation, VCM. And which is the second velocity? Velocity because of rotation. So this is rotational velocity is how much? Vt1, which is equals to omega into r. Okay. Therefore, what is the total velocity of this system of point V? Velocity of first point is how much more? Velocity of center of mass plus omega into r. Can I write like this? Both of them, they are in the same direction. No? Definitely I can write like this. Clear now? Now I will take second point. Second point has how many speeds? 2 speeds. What are the 2 speeds? Velocity of center of mass is in which direction? Velocity of center of mass is in this direction. Translational velocity. Velocity because of movement in a straight line. Okay? And because of rotation, it has a tangential speed in this direction, and how much it is? Omega into r. So therefore it has one more velocity, which is called Vt2, and which is equals to omega into r. Okay. Now these two velocities, they are at an angle of how much? 90 degrees. No? They are present at an angle of 90 degrees. Okay. Therefore what will be the velocity of point 2? Total velocity is equal to square root of Vcm whole square plus omega into r whole square. Can I write like this? When two vectors are at an angle of 90 degrees, then this is the resultant vector number. So velocity of this point will be this much. Or if you want to draw in the form of diagram, let us draw it. So this is what? This is Vt2, which is equals to omega into r. Then two vectors are joined tail to tail number. This is the resultant vector. Okay. So resultant vector is V2. So therefore V2 is this much. Are you able to understand? It means this point's velocity will be in which direction? This point's velocity will be in this direction. Because it has two velocities. Velocity because of translation also, velocity because of rotation also. Are you able to understand? Let us see third point, this point. Okay. What about third point? How many velocities are there? Again two velocities. What are they? Velocity because of center of mass. Okay. Center of mass is moving in this direction. Clear now? Then what about velocity because of rotation? Again same, Vt3 omega into r. So it will have one more velocity, which is Vt3, which is omega into r. Are you able to understand? Then what is the net velocity of point 3? What is the net velocity of point 3? You cannot say it is 0. Why? Because did I say that velocity of center of mass and Vt3 are they equal? Magnitude wise are they equal, did I say? I did not say. Then how can you say it is 0? Just you have to subtract them, that's all. Clear now? So V3 is equals to velocity of center of mass minus omega into r. Okay. Or also you can write V3 is equals to, okay, omega r minus velocity of center of mass. Like this also you can write. They are acting in opposite direction. No? Just you have to subtract. Are you able to understand? Now let us take velocity of point number 4. Point number 4 had how many velocities? This velocity. One velocity is velocity of center of mass. Okay, ma? Velocity because of translation. One more velocity, rotational velocity. Rotational velocity is in which direction? Tangential velocity is Vt4, which is equals to omega into r. It is in this direction. So again they are present at an angle of 90 degrees. No? Are you able to understand? No? So therefore, this is the resultant velocity. Velocity at point number 4. So therefore, velocity at point number 4 is how much? Square root of Vcm whole square plus omega r whole square. That's it. So this is how, for example, this is a rotating body as well as it is translating also. Then each point will have different velocity. Okay. Now total how many points I have taken? 4 points. Point number 1, point number 2, point number 3 and point number 4. Out of all of them, which point has highest speed? Can you say? First point has highest speed. Why? Because both velocities we are adding them, no? Add just to direct ga. So this point has highest speed. Which point has minimum speed? This point, point number 3 has minimum speed. Because velocities we are subtract. Which point have speed in between maximum and minimum? Point 2 and point 4. They are not maximum, they are not minimum. Are you able to understand? So therefore, what is the conclusion I can draw here? Conclusion is that velocity of first point is maximum. Okay, ma? Velocity of third point is minimum. Are you able to understand? And speed of point number 2 and speed of point number 4, it is equal. But directions are different. Okay, ma? See, ma, here, this velocity is in this direction, this velocity is in this direction. E point ki velocity e direction lo untundi, e direction lo. E point ki velocity e direction lo. But magnitude wise they are equal, no? Value wise they are same, no? So velocity of point number 4, speed of point 4 and speed of point 2, they are equal. Speeds are equal. Velocity is equal, because directions are different, no? Velocities are not equal, speeds are equal. So I can say speeds of 2 and 4 are equal. So understood now how to understand velocity of each point when bodies are undergoing a combination of translational as well as rotational motions. Rendu kalipi jarugutunnayi ikkada. Okay? That's it. Okay? Make a note of this. Let us discuss about this point, point number 3. See ma here. So velocity of center of mass and tangential speed, they may be equal, they may not be equal. Equal undachu undakapochu. Clear ma? So therefore what I can write here, I can write some cases, 3 cases. Okay. So the 3 cases which I can write is, okay, case number 1. I am writing for which point? Point number 3. Okay, ma? First case is that velocity of center of mass can be greater than tangential speed. It is possible, no? Thank you. Clear, ma? So this velocity, which is called translational velocity, may be greater than rotational velocity. Okay. Then net velocity will be in which direction? Net velocity will be towards positive x-axis. Are you able to understand? Ma? So in this condition, then Vcm minus Vt3 will be the velocity of point number 3. And it is towards which direction? Towards positive x-axis. Are you able to understand? Next, case number 2. The second case which is possible is tangential speed may be greater than speed of center of mass or velocity of center of mass. This is also possible, no? This velocity may be greater than this velocity. then what is the net velocity of point number 3? Vt3 minus Vcm. అంతే కదా, బిగ్గర్ లోంచి స్మాలర్ తీసేయాలి కదా. సో Vt3 may be greater than Vcm. Are you able to understand? Then this velocity will be towards which direction, ma? It will be towards negative x-axis. Are you able to understand? So if velocity is greater than this velocity, then net velocity will be towards positive x-axis. Otherwise it will be towards negative x-axis. Case number 3. Case number 3 is that velocity of center of mass may be equal to tangential speed. This case is also possible, no? Velocity of center of mass. What is meant by velocity of center of mass? Translational velocity. Vt3 means rotational velocity or tangential velocity. Both this velocity may become equal also, no? Okay, ma? If they are equal, then what is the velocity of point number 3, ma? Velocity of point number 3 will become 0. That's all. It means this point is temporarily in a rest position. Can I call like that? If this velocity and if the velocity, if they are equal and opposite, then velocity of this point will be how much? 0. A point rest lo untundi kada. It means this point will be temporarily in rest position. And that condition is exactly what is called as rolling. A condition emanta manamu rolling condition anta. Okay ma? So case number 3 is a case of rolling condition. Wheels roll avutaya, slide avutaya, translate avutaya. బైక్లో వెళ్ళారా లేదా ఎప్పుడన్నా? ఆ వీల్స్ రోల్ అవుతాయా, ట్రాన్స్లేట్ అవుతాయా, లేదా రోడ్డు పైన స్కిడ్ అవుతూ వెళ్తాయా? రోల్ అవుతూ. రోలింగ్ మీన్స్ దిస్ ఇస్ ద కండిషన్. ఓకేమా? ఇఫ్ యూ టేక్ ద పాయింట్ విచ్ ఈజ్ ఇన్ కాంటాక్ట్ విత్ ద గ్రౌండ్, సో అవుట్ ఆఫ్ 1, 2, 3, 4 points, which point will be in contact with the ground? This point will be in contact with ground. So this point's velocity, if it is 0 temporarily, then such motion I can call it as rolling motion. Okay, and what is the condition for rolling? Translational speed and tangential speed, they should be equal and opposite. Are you able to understand? So therefore this is the condition of what? This is the condition of rolling condition. Understood now? These two, they are not rolling conditions, only this one is the condition of rolling condition. Okay, so right now, so therefore our next concept is what? Our next concept is rolling. Understood now, ma? Rolling. So what is meant by rolling? So the point of wheel in contact with the ground, if it is temporarily at rest position, if it is temporarily at rest position with ground, then wheel is said to be rolling. Wheel is said to be rolling. Are you able to understand, ma? Wheel roll outu undi ani artham. Clear? So therefore what I write here, velocity of translational is equal to velocity of rotational. Then the condition is called as a rolling condition. Okay, ma? Or you can say velocity of point number 3 is 0. Or also you can say velocity of center of mass is equals to tangential velocity of point number 3. So this condition is exactly what is called as rolling condition. Are you able to understand, ma? That's it. Okay. Understood now what is meant by rolling? The point which is in contact with the ground, temporarily it should be in rest position. Wheel anta motion untundi, kani aa point ki motion untundi. Is it clear? That point will be in rest position. Okay. Shall I rub this? It will be temporarily at rest position. Now see. So if I want to calculate kinetic energy of this rolling body, total kinetic energy, then this body is having two motions, no? So it is translating also, moving in a straight line. It is rolling also. So therefore total kinetic energy is kinetic energy because of translation plus kinetic energy because of rotation. Both energies will be there now. Clear now? So kinetic energy of translation is how much? It is half m v center of mass square. So this is the kinetic energy of a translating body which is moving in a straight line. Clear now? Kinetic energy of rotation is how much? Half I center of mass into omega square. This is the kinetic energy because of rotation. Half I omega square only. No? Are you able to understand? No? So kinetic energy because of translation, kinetic energy because of rotation. Okay. So therefore, Sima, I center of mass, moment of inertia of this body about the center of mass can be written as mk square also. No? Kinetic energy can be written as, moment of inertia can be written as mk square also. Do you remember? We have studied a concept called radius of gyration, no? Radius of gyration, where total body I will convert into a point mass and I will rotate at a distance of k. Then moment of inertia of original body and moment of inertia of point mass both should be equal. So I is equal to mk square also I can write. Are you able to understand? So therefore take this value and substitute here, then what I will get? So total kinetic energy is equals to, so half mv center of mass square plus a half, instead of I center of mass I can write mk square multiplied by omega square. I can write like this. No? Are you able to understand? No? Next we know that Sima, I can write up to here. V tangential is equals to omega into r. This relation also I can write now. Tangential speed is equals to omega into r. This also I can write. Okay, now see. Now see here, let us consider this point to be our temporary axis of rotation. I can consider this also. No? Okay, ma? I can consider this point to be my temporary axis of rotation. If I consider this point to be my temporary axis of rotation, then what will be the tangential speed of this point? What will be the tangential speed of this point? Ma? V center of mass will be how much? Are you able to understand? Listen carefully. See ma. So if point P is taken as temporary axis of rotation, temporary axis of rotation. Already we discussed this concept, no? So this point is in rest position, no? In rolling condition, this point is in rest position. So I can assume this total body is rotating about this point. I can assume like that. No? So this point I can also call it as instantaneous axis of rotation, IAR. What is meant by IAR? Ma? Instantaneous axis of rotation, or you can call temporary axis of rotation. Okay. So therefore I can call it as instantaneous axis of rotation. Instantaneous axis of rotation. Okay. అంటే టెంపరరీగా బాడీ ఈ పాయింట్ చుట్టూ తిరుగుతుంది అనుకోవచ్చు. Temporarily I can assume this total body is rotating about this point. That is why it is called instantaneous axis of rotation. Okay. Okay. Now if I am taking this point to be my temporary axis of rotation, are you able to understand? Ma? This point I am taking to be instantaneous axis of rotation. And what is the angular velocity of this total body? Angular velocity is omega. Okay. అంటే ఈ పాయింట్ చుట్టూనే ఇది రొటేట్ అవుతుంది అనుకుందాం మనం. Are you able to understand? It means after some time body will travel like this, after some time body will travel like this. That is called instantaneous axis of rotation. Okay, ma? Now can you say what will be the velocity of center of mass? Ma? I will write here. So this point is point B, which is instantaneous axis of rotation, the point which is in contact with the ground, and it is rotating with an angular velocity of omega. Are you able to understand? Now this velocity is called V center of mass, number velocity of center of mass. If this is the axis of rotation, this is a tangential velocity also. If this is the axis of rotation, ఈ పాయింట్ దగ్గర tangential velocity ఎంత ఉంటుంది చెప్పండి? How much will be the tangential velocity at this point? What is the distance from the axis of rotation? Distance చెప్పండి. Distance of this point from axis of rotation is r. Then what is the formula for tangential speed? V tangential is equals to omega into r. That's all. Are you able to understand? So at this point, tangential speed is omega into r, and that is nothing but velocity of center of mass. Can I call like that? This point will have how much speed? Velocity of center of mass. And velocity of center of mass, if I write in terms of tangential speed, then how much it is? Omega into r, because total disk angular velocity is omega. And what is the axis of rotation? Distance from axis of rotation is r. So I can write V center of mass is equals to tangential speed is equals to omega into r. Okay. Similarly, if I take this point, are you able to understand? Let us call this point as point number 1. Now can you say what is the tangential speed of point number 1? Can you say? Tangential speed of point number 1 ఎంత ఉంటుంది? Tangential speed of point number 1 will be how much? What is the formula for tangential speed? Omega into what? This is the axis of rotation, no? So omega. But what is the distance from the axis of rotation? R plus r, 2r. 2r distance is there, no? So omega into 2r I have to write. Are you able to understand? Or also I can write it as 2 into omega r. Omega r is nothing but velocity of center of mass, no? So therefore I can write it is 2 times of velocity of center of mass. Are you able to understand now what is happening? If I take this point to be my instantaneous axis of rotation, it means if disk is rotating about this point, then this point will have a tangential speed of omega into r. This point will have a tangential speed of 2 into omega into r, which is equals to 2 times of velocity of center of mass. Is it clear? Okay. Now let us go to the same calculation here. So can I write Vt is equals to omega into r is nothing but velocity of center of mass? I can write no more. So therefore instead of omega, what I can write? Can I write V center of mass divided by r? I can write no. So therefore instead of omega, I can write V center of mass divided by r. So take this value and substitute here. Are you able to understand? No? Therefore what is the total kinetic energy? Clear? No? So total kinetic energy is equals to half m V center of mass square plus half m k square multiplied by V center of mass divided by r whole square. I can write like this. Are you able to understand? So just instead of omega, what I have written ma? V center of mass divided by r. Okay. Now let us see what are the terms which are constant here. So half m V center of mass square, they are constant. Half m V center of mass square. And what are the terms I am left with? 1 plus k square divided by r square. Okay, ma? So this is another equation to calculate total kinetic energy of a body which is in rolling motion. Are you able to understand, ma? So this is the equation for what? In the case of rolling motion. Are you able to understand, ma? So when a body is rolling, what is the total kinetic energy I can write? Half mv center of mass square multiplied by 1 plus k square divided by r square. So while studying moment of inertia only, we discussed about k square by r square. Do you remember? K square by r square denotes shape of a body. Chadukunnam kada already. K square by r square denotes what? It denotes shape of a body. If k square by r square is 1, then it is a ring. K square by r square, if it is 1 by 2, then it is a disc. K square by r square, if it is 2 by 5, it is a solid sphere. K square by r square, if it is 2 by 3, then it is a hollow sphere. Raskunnam kada already. Gurtunda? So to make the calculations easy only, we have tried to convert this total kinetic energy equation in this form. Is it clear, ma? Come on, make a note up to here. Okay. So therefore what we have studied, so total kinetic energy is equal to half m v center of mass square multiplied by 1 plus k square divided by r square. This is the equation. Why I have written in this form? Because for rolling bodies, k square by r square denotes shape of a body and nature of the body. So k square by r square denotes shape of a body. Shape of a body, instead of shape of a body, I better write type of a body. Okay, ma? So k square by r square, if it is 1, okay, ma? Then that body is a ring, and that body may be a point mass also, but point mass cannot roll, no, ma? So k square by r square value, if it is 1, then it is which kind of body? It is a ring. Okay, ma? So k square by r square, if it is 1 by 2, then it is what? It is a disk. Okay, so k square by r square, if it is 2 by 3, then it is a hollow sphere. Okay, similarly k square by r square value, if it is 2 by 5, then it is a solid sphere. Are you able to understand? So whatever may be the type of body given, just you take that value of k square by r square, substitute in this equation, then you will get the equation of total kinetic energy. Okay, clear? Now after this, let us do some more analysis on rolling bodies, which is very important. Okay, ma? Now see, consider this is a rolling body. Okay, so therefore this point will have velocity of center of mass number, and this point will have two speeds. So tangential speed, velocity of center of mass, and it will have tangential speed also. So let us consider this is point P. So for rolling, what is the condition to be followed, ma? For rolling, velocity of point P should be how much? Velocity of point P should be 0. Okay, ma? It is possible in which condition? Only when velocity of center of mass and tangential speed, if they are equal. Okay, now you take this point to be axis of rotation. Okay, previously we have taken this point to be our axis of rotation number. Previously we have taken this point to be temporary axis of rotation. Now I am taking this point to be axis of rotation. This would rotate avutundi kada din chuttu. Okay, this point to be my axis of rotation. Then can you say what is the tangential speed of this point? What is the tangential speed of this point? Minus r. Just you say the magnitude, no need of directions. Magnitude of tangential speed of point P is how much? Now we are considering this body is rotating about this axis. So what is the perpendicular distance from the axis of rotation? Perpendicular distance is r. Clear now? So therefore tangential speed of point P is how much? Tangential speed of point P is omega into r. Okay, and tangential speed of this point is nothing but velocity of center of mass. Are you able to understand now? Ante kada. So velocity of center of mass ఎంత ఉంటుంది velocity? It is also nothing but omega into r. అర్థమవుతుందా? At this point we have only VCM, no? At this point we have only VCM. Tangential speed is not there at the middle, because this point where it is present on the axis itself. Tangential speed will be 0. So this point will have only velocity of center of mass, and velocity of center of mass is equal to tangential speed. Tangential speed is how much? Omega into r. So therefore velocity of center of mass is how much? Omega into r. Okay, are you able to understand? Now you take this point. Let us call this point as point number 1. This point will have how many speeds? This will have velocity of center of mass also. Are you able to understand, ma? This point will have tangential speed also. Are you able to understand? So what is the velocity of point number 1? Velocity of point number 1 is velocity of center of mass plus tangential speed. Okay, now can you say what is the tangential speed of this point if this is the axis of rotation? This is the axis of rotation anukunte ee point ki tangential speed enta. What is the perpendicular distance? R only, no? Again how much? Omega into r only. So Vt1 is omega into r. So V1 is equals to V center of mass plus omega into r. V center of mass already we have calculated, no? V center of mass is how much? Omega into r, so V1 is equals to omega into r plus omega into r. Total how much? 2 omega r. So in the previous condition also same answers I got, no? Are you able to understand? చెప్పేటప్పుడు చాలా కేర్ఫుల్గా వినాలిరా, అన్ని పాయింట్స్ కవర్ అయ్యి ఉంటాయి. సో అండర్స్టూడ్ నమ్మా డిఫరెంట్ మెథడ్స్ ఆఫ్ క్యాల్కులేటింగ్ వెలాసిటీ ఆఫ్ డిఫరెంట్ పాయింట్స్. సో see, let us try to understand once again. See, so this is a rolling body. So in a rolling body, if I take this point to be instantaneous axis of rotation, this is my axis of rotation, then the body is undergoing which motion? Only rotational motion. It is not translating. Okay ma? In this condition only which motion? Only rotational motion. Why only rotational motion ma? Because this axis, it is in rest position, no? This axis for a rolling body, ee point rest lo undali kada. It means this axis is in rest position. If axis is in rest position, it means only rotational motion. Body is not undergoing translational motion. Are you able to understand ma? So therefore no translational motion. Translational motion ledu. Okay. Therefore if you take this point, it will have only tangential speed. Let us take this as V22. How much? It will be omega into r, because perpendicular distance is r. If I take this point as point number 1, are you able to understand ma? Then what will be its tangential speed? Again omega into r only. From the axis of rotation, what is the total distance? R plus r, 2r. So omega into 2r. Clear no ma? So 2 omega into r. So therefore tangential speed of first point is 2 times of tangential speed of second point. So here I am taking, this is the first point, this is the second point. Okay, this is how I have calculated, by taking which one to be my axis of rotation? This point to be my axis of rotation. Now it is clear, no? Idi axis of rotation ga తీసుకుంటే every point will have only rotational velocities only tangential velocities only. Are you able to understand? Understood now? So if you are taking this one to be your axis of rotation, then every point will have only tangential speed. Velocity of center of mass is not there. Are you able to understand ma? Similarly, now if you take this one to be my axis of rotation, middle point to be my axis of rotation, then this axis of rotation is moving also. This axis of rotation is moving also. Are you able to understand ma? So therefore if I take this to be my axis of rotation, then rotational motion is also present, translational motion is also present. Are you able to understand ma? So therefore in this condition what I have to write here, let us call this point as point O. If O is taken as axis, okay ma, then axis is also moving. Axis is also moving. Therefore body has translational as well as rotational motions. So if I take this one to be the axis of rotation, then it will have translational motion also, rotational motion also. Are you able to understand me? Therefore at every point, both velocities means what? Velocity because of translation, comma velocity of rotation should be considered. Are you able to understand? If I take this to be my axis of rotation, then at every point Or if I take this point, body is rolling now in this condition. If I take velocity of point P, velocity of point P should be how much? Velocity of point P should be how much? 0. How I got 0? Because I have two velocities now in opposite directions. Okay, are able to understand ma? Velocity of center of mass and tangential speed both are equal and opposite. That is why velocity of point P is how much? 0. And if you take this to be the axis of rotation, then what is the tangential speed ma? Ee point ki tangential speed ఎంత ఉంటుంది? Tangential speed will be equal to omega into r. Because radius is how much? Radius is r. Angular velocity is omega. Omega into r. Are you able to understand? Now if you take middle point, this point will have only velocity of center of mass. So therefore velocity of point O is nothing but velocity of center of mass. And velocity of center of mass is how much? Omega into r. Okay? So therefore tangential speed and velocity of center of mass, both of them, they will be equal when body is rolling. At which point? At point P only. Are you able to understand? Similarly, if I take point number 1, here I should take two velocities, no? Are you able to understand, no? So velocity of center of mass is in this direction, translational speed also in the same direction. Okay? So therefore velocity of center of mass is how much? Already I have calculated. Velocity of center of mass is omega into r. Now what is the tangential speed of this point? Again omega. What is the perpendicular distance? R only. So omega into r plus omega into r. So how much? 2 omega into r. Okay. So therefore what I can write? Velocity of first point, this point, is equal to 2 times the velocity of point O, which is point O, this point. Are you able to understand? R I can write it is 2 times of velocity of center of mass. I can write like this also. Okay. So here and here, understood the difference now, how we are doing the calculations? Here we are taking this one to be the axis of rotation, but axis is also moving. So at every point I have to take two velocities. Here also two velocities, here also two velocities, but here only one velocity, because here tangential velocity is how much? 0. మధ్యలో అదేం రొటేట్ అవ్వటం లేదు కదా. So its tangential velocity will be 0, only velocity of center of mass will be there. But here what is the method of calculation? This I am taking to be my axis of rotation. So this point has tangential velocity, this point also has only tangential velocity. Then also I will get the same answers. Clear now? That's it. That is anybody? See ma here. So this is a sphere ma, which is rolling. Are you able to understand? So it is a rolling sphere. So on the rolling sphere, a plank is held by a man. On the rolling sphere, person is placing a plank. And when sphere is rolling, plank is also moving on the what you call this sphere, and a man is holding that plank. Okay. So by the time this sphere covers a distance of 10 meters, plank and the man will cover how much distance? If the sphere is rolling, plank also is moving along with it, and plank is not sliding. Plank is not sliding on the sphere. It is moving along with the sphere. Are you able to understand? So therefore by the time the sphere covers a distance of 10 meters, so what will be the distance covered by the man? That is the question. How can you answer? Chapandi. Okay, ma? So yesterday already we have studied, Nama. See here. Consider this is a rolling body. What kind of body? This is a rolling body. Are you able to understand? So rolling body, if I take this one to be my instantaneous axis of rotation, then body is undergoing only rotational motion, Nama. It is not having any translational motion. Now if you take the center of mass of this sphere, then velocity of center of mass is nothing but tangential speed at the center, Nama. If it is rotating, it has only Which kind of velocity? It has only translational velocity. Sorry, it has only rotational velocity if this is the axis of rotation. Are you able to understand? So, what is the tangential speed of the middle point? Tangential speed ఎంత ఉంటుంది దానికి? Tangential speed, it is at a distance of r number, this point. So, tangential speed formula is omega into r. Are you able to understand? So, this point, middle point, where center of mass is present. So, this is having a tangential speed of omega into r. Okay. Similarly, if I take the topmost point, the point where this plank is attached. Are you able to understand, ma? If you take this topmost point and let us call this is point number 1 and let it be point number 2. Then this point number 2, it will have a greater tangential speed, no? Because it is at a very large distance from the axis of rotation. So if point is present at a large distance from the axis of rotation, tangential speed will be greater, no? Clear now? So tangential speed of this one, let it be Vt2. So what is the tangential speed of this point? Omega into r. But what is r value? R value is r plus r. So this is another r number. So from the axis, what is the total distance? R plus r, 2r. So therefore tangential velocity is omega into 2r. This is what we have studied now in the last class. So therefore how much it is? 2 omega into r. It means that when compared to the central point, this topmost point has how much speed? It has double the speed to that of velocity of center of mass, or when compared to the middle point of the disk. Are you able to understand? No? What about the speed of this point? If I call this point as point P, velocity of this point will be how much? How much? 0, because this is the point which is in contact with the ground. No? For rolling bodies, the point which is in contact with the ground, it does not have any velocity. Okay. Now, by looking at this data, can you say, if a disk or a sphere moves by a distance of 10 meters, then plank moves by how much distance? Yeah? 20 is the answer. Sima, distance moved by the sphere depends on what? Distance moved by the sphere depends on velocity of center of mass. Sphere is moving in a straight line with how much speed? With the velocity of v center of mass. Correct, no? But when compared to this velocity is double, no? Okay. So if the sphere moves by 10 meters, the plank which is in contact with the sphere on the topmost point, it will cover double distance. Why it will cover double distance? Velocity is double. Are you able to understand, ma? So therefore what I can say, therefore plank moves by how much distance? 2 into 10, 20 meters. Meters only now again. So therefore man also moves by how much distance? Man also moves by 20 meters. That's all, that is mass. Are you able to understand, man? Very simple concept. Okay. Because velocity of point number 2 is 2 times of velocity of point number 1. Okay. So therefore distance travelled by point number 2 will be double of distance travelled by point number 1. And what is the distance travelled by point number 1? It is nothing but distance moved by center of mass. Distance moved by center of mass is nothing but distance travelled by sphere. Distance moved by sphere. That's all. Are you able to understand? Very simple point. Are you able to understand? So if I don't want to do in this method, can you suggest any other method? First of all, make a note of this one, then we will study the second. I will do by using this point to be my axis of rotation. In the first case, method number 1, I have taken this point to be my axis of rotation. This axis ga తీసుకున్నాను. So then body has only which kind of motion? Body has only rotational motion. Understood, no? When I take instantaneous axis of rotation at the point which is in contact with the ground, then body has only rotational motion. But instead of that, what I can do instead of that, I can take this point to be my axis of rotation. Okay? Middle point of the sphere. If this is the axis of rotation, then the center of mass is also in movement. My axis is also in movement. Here axis is in rest position. Ikkada axis temporary ga rest lo untundi. But here axis is also moving. So here I write axis at rest. Okay. But here axis is in translational motion. Axis is in which motion, ma? It is in translational motion. If axis is also moving, then body has two types of motions. No? It has translational motion also, it has rotational motion also. That's all. Are you able to understand? Okay. Now if you take this point which is in contact with the ground, again this point will have two velocities. No? Okay, ma? One velocity is velocity of center of mass because of movement in a straight line, translational velocity. Okay, ma? And because it is rolling in this direction, it will have tangential speed also. This point will have tangential speed also. That's all now. But the body is rolling, no? Body is rolling. Rolling means what? Velocity of center of mass and tangential speed, they should be equal and opposite. That's all now. So therefore I can write tangential speed is equals to velocity of center of mass. And they are equal and opposite. So if I take this point as point P, then what is the velocity of point P? Velocity of point P is 0. It is not in movement. Are you able to understand? Then what about the point which is present in the middle? It has only translational motion. This point is not rotating. No? Perpendicular distance from the axis of rotation is how much? 0. Axis దానిపైనే ఉంది కదా. Axis is present at point number 1 only. So therefore it doesn't have any tangential speed. Rotation వల్ల దానికి speed ఉండదు. Why? Because tangential speed omega into r. R is perpendicular distance from axis. No? What is the perpendicular distance from the axis? 0. Axis is there only. So it doesn't have Vt. Tangential speed is not there. Velocity because of rotation is not there. Which velocity is there? Only velocity of center of mass is there. Only translational velocity is present. Are you able to understand? So shall I write that point also? I will write that point also. Point number 1 does not have which velocity? Rotational velocity. Rotational velocity, in brackets you can write tangential velocity. Tangential velocity. What is the reason? That also I will write here. Okay. What is the reason of this one? Tangential speed of point number 1 is omega into r normal, but what is r value? 0. Omega into 0, so it is equal to 0. For which point? For point number 1. Axis నుంచి perpendicular distance ఏమీ లేదు కదా, అక్కడే ఉంది అది. So it is 0. But it has velocity of center of mass normal. But point number 1 has which velocity? Velocity of center of mass. Translational velocity is there, movement in a straight line. And velocity of center of mass is equal to how much? Vt. Okay, ma? Velocity of center of mass is Vt. Or Vt at point P, that is better. Tangential speed at point number P. Are you able to understand? And what is the tangential speed at point P? Tangential speed at point P, this is the axis of rotation. ఇప్పుడు axis of rotation ఇది. So this point is present at how much distance? At a distance of r. So tangential speed formula omega into r. Satisfied? So this point number 1 has how much velocity? Omega into r. This is the same answer I got by taking instantaneous of axis of rotation also. IR తీసుకున్నప్పుడు కూడా ఇదే వచ్చింది కదా. Okay. Similarly, let us take point number 2. This is point number 2. Now point number 2 will have how many velocities? 2 velocities. What are they? So one velocity is velocity of center of mass because of translational motion. Similarly, disk is rotating also, no? So it will have which velocity? Tangential velocity at point number 2. Are you able to understand? Rendu velocities ఉంటాయి కదా, because now this is the axis of rotation. Are you able to understand? No? So every point will have 2 velocities. Tangential velocity also, translational velocity also. Tangential velocity ante emani? Velocity because of rotation. Tangential velocity means velocity because of movement in a straight line. Okay, ma? So write down. So velocity of point number 2 is how much? Tangential velocity plus velocity of center of mass. That's all, no? Now this point is present at how much distance from the axis? R distance. Clear now? So therefore what is its tangential speed? Omega into R. And velocity of center of mass already we have calculated, no? Velocity of center of mass is how much? Omega into R. So how much? 2 omega into R. Again I got the same result. But which one was easy? Instantaneous axis of rotation was very easy, no? By taking that point to be the axis of rotation, it means only body is undergoing rotational motion. Just you calculate omega R values, that is my answer. Okay, so whatever it may be, again I got the same result, you know, when compared to point number 1, which is point number 1. When compared to point number 1, where I have calculated point number 1, this is point number 1, V1. Okay, this is not V1. V1 where I have calculated? Okay, I will write here. So V1 is nothing but omega into R. That's all now. At point number 1, only velocity of center of mass is there, no? And that is equal to omega into R. But point number 2 has how much velocity? 2 omega into R. So it means definitely when compared to this point has double speed. So therefore distance moved also will be double. Again same discussion. That is my answer. So like this also I can do. Are you able to understand? That's it. So therefore V2 is equals to 2V1. Now again this total discussion you can write. So see this question. So this is a disc which is rolling, and it is rolling with a speed of 10 meters per second, and radius of this disc is 2 meters. Okay ma? Then 3 points are given ma. Point number 1, point number 2, they are present on the circumference, but point number 3 is present somewhere on the surface of the disc at a distance of 1 meter from the axis of rotation. Okay ma? Then we are supposed to find out this point, these speeds of these points. Now let us see ma here. So disc is rolling with a speed of 10 meters per second. What is this velocity? Disc 10 meters per second speed to veltundante em velocity adi? That is the translational velocity of the disc. That's all, nama. Translational velocity of the disc, which is also called as velocity of center of mass. Disc center of mass will be here, no? So center of mass is traveling with a speed of 10. It means the disc is also traveling with a speed of 10. That's it. Are you able to understand? So, and it is given as how much? 10 meters per second. Okay, now let us take, for example, let us take this point as point number 4. This is a rolling body, no? What kind of body, ma? Rolling body. Are you able to understand? So in rolling body, if you take, or let us call it as point number P, because previously also we called it as point number P, no ma? Velocity of point number P should be how much? This is 0. Velocity of the point which is in contact with the ground, that is always 0. Okay. So this point will have 2 velocities too. This point will have 2 velocities. One is velocity of center of mass in the same direction. Because disc is moving in this direction, this same point will have tangential speed also. Both of them, they should be equal, no? So therefore what I write? So tangential speed of point number P and velocity of center of mass, they should be equal, and it is equal to 10 meters per second. Okay. So tangential speed at point number P I got. Are you able to understand, ma? So now let us take point number 1. Clear? Point number 1. Okay. So at point number 1, how many velocities will be there? Again 2 velocities. Velocity of center of mass will be in this direction. Disc anta translate avutundi kada. It means every point is moving in a straight line. Clear? Similarly, disc is rotating also, no? So because of rotation, it will have tangential velocity of point number 1. Okay, ma? See, ma, tangential speed of point 1 and tangential speed of point P both are same, no? Because both of them, they are present at same distance of R. Are you able to understand? So therefore, if I take point number 1, there are 2 velocities. One is velocity of center of mass, another one is tangential speed of point number 1. So therefore, what is the resultant velocity? This is the resultant velocity. So this is the total velocity of point number 1. Alage the resultant తీసుకుంటే. Okay ma? Because they are present at an angle of 90 degrees, V1 is equals to square root of VT1 whole square plus VCM whole square plus 2 into VT1 into VCM cos 90. Because angle between the vectors is 90, no ma? So this total term will become 0 because cos 90 is 0. Okay. So therefore velocity of point number 1 is square root of Vt1. Vt1 is nothing but omega into r. This is present at a distance of r number, tangential speed. So omega into r whole square plus velocity of center of mass whole square. Clear? So therefore no need of substituting this also, ma. So now see, Vt1 I can write omega r also. Vt1 and Vtp both are same, no? Clear, no? I can say that tangential speed of point number 1 and tangential speed of point number p, similarly tangential speed of point number 2, all of them they are equal. This point and this point will have same tangential speed, no? Because all of them they are present at how much distance? They are present at a distance of r. And angular velocity of every point is same. In similarities we have studied, no? In rotational motion, similarities and dissimilarities chadunam kada. Angular velocity of every point will be same, but tangential speeds will be different. So how much it is? It is equal to 10. So substitute 10 there. Directly I can substitute. So 10 square plus velocity of center of mass is already given. It is also 10 square. Clear? So therefore velocity of point number 1 is how much? So how much? It is 10 root 2 meters per second. That is my answer. Okay. And you can calculate angle also. So velocity of point number 1 is present at what angle with respect to horizontal or with respect to vertical. For example, if you take this angle as alpha and if you take this angle as beta, then tan alpha, how can I calculate? Tan alpha, how can I calculate? Tan alpha, opposite by adjacent. Opposite is nothing but Vt1, no? And this is Vcm. Clear, no? So Vt1 divided by Vcm. Both are same, no? So I will get 1. So therefore alpha is equal to 45 degrees. If alpha is 45 degrees, beta is also 45 degrees. So you can calculate the angle of velocity, resultant velocity also. And this also questions can be asked. Are you able to understand? So I have calculated velocity of point number 1, no? Now can you say how can I calculate velocity of point number 2? Velocity of point number 2. Come on. Point number 2 is present here, no? So here how many velocities are there? 2 velocities are there. What are they? Or just you can write it is 2 omega r. Already we calculated, no? Or just you can say it is 2 times of velocity of center of mass. Already we discussed many times. So that's all, that is my answer. So velocity of point number 2 is how much? 2 into velocity of center of mass. So 2 into velocity of center of mass is 10. So it is 20 meters per second. That is my answer. Understood? No? When compared to this velocity will be double, no? Ante kada. Or you can write like this. So velocity of point number 2, it will have 2 velocities. What are the 2 velocities at point number 2? So one is tangential velocity of point number 2 and the another one is velocity of center of mass. Like that also you can. But if you add both of them, you will get 2 omega into r. Okay? It means 2 times the velocity of center of mass. So therefore if its velocity is 10, velocity of this point is 20. Okay? Okay, up to here it is fine. Now I want to calculate velocity of point number 3, which is not present on the circumference, which is present at a distance of only 1 meter from the axis of rotation. And angles also, it is not 90 or it is not in the same direction, they are not in the opposite direction also. Okay? First of all, make a note up to here. Let us see this point number 3, see here. This is point number 3, no? This is the center of mass. So from the center of mass, point number 3 is present at a distance of 1 meter. Are you able to understand, ma? So here also this point will have 2 velocities, no? One is velocity of center of mass, another one is tangential velocity. Clear, no? So this is the radius. So tangential speed will be always perpendicular to radius, no? Tangential speed ela untundi, radius ki perpendicular ga untundi. Radius ki perpendicular. Clear, no? So this is the radius. To this radius it is perpendicular. So therefore what is the total angle between 2 velocities? This angle already he gave, it is 37. Oh, which angle he gave 37? No? Sorry. So this angle he gave 37. This angle is given 37, no? If this angle is 37, this is 90. Here 90 degrees will be there, no? This angle will be 53. This angle will be how much? 53. Okay. And the angle between radius and velocity vector is 90. So 90 plus 53 total how much? 90 plus 53. 143. Clear now? Are you able to understand? So the total angle between velocity of center of mass and tangential speed is how much, ma? 143 degrees. Okay. Now velocity of center of mass is how much? It is already given, no? Velocity of center of mass is 10 meters per second. Now can you say what will be the tangential speed of point number 3? Tangential speed of point number 3 will be how much? What is the tangential speed of point P? Point P, tangential speed. Tangential speed is 10 only. Tangential speed of point number 1, 10 only. Tangential speed of point number 2, 10 only. Tangential speed of point number 3, it will be 5 only. 5. Why it will be 5? Because radius is half, no? When radius is 2 meters, velocity was 10. Radius is half. Tangential speed depends on radius. Already we have studied, no? What is the formula of tangential speed? Omega into r. If r is a 10 meter, tangential speed is 10. Sorry, if radius is 2 meter, tangential speed is 10. But radius is only half, 1 meter. So tangential speed also will be half, 5 meters per second. Understood now? Now, this 10 meters and 5 meters, they are present at how much angle? 143 degrees. Now substitute the equation. So therefore, okay. So therefore, total velocity of point number 3 is how much? It is equal to square root of 10 square plus 5 square plus 2 into 10 into 5 into cos 143. Okay, ma? So do this calculation, that is my required answer. Clear now? Cos 143 can be written as cos 90 plus 53. Okay, ma? It is sin 53. Sin 53. So sin 53 value, it is 4 by 5. But cos 143, it is present in second quadrant number, so I will get minus 4 by 5. So velocity of point number 3 is how much? Square root of 100 plus 25 plus 2 into 10 into 5 into minus 4 by 5. Now I hope you can do this total calculation. That is my required answer. Okay, ma? That's it. సిలిండర్ కార్పెట్ను మడతేసుకుంటూ వెళ్ళాం అన్నమాట, ఇలా సిలిండర్ లాగా. సో ఇట్ బికేమ్ ఎ సిలిండర్ ఫైనల్. క్లియర్ నౌ? సో దేర్ ఫార్ లెట్ us కన్సిడర్, సో కార్పెట్ హ్యాస్ బికమ్ లైక్ దిస్. ఇట్ మీన్స్ ఇట్ హ్యాస్ బీన్ కన్వర్టెడ్ ఇన్ టు ఏ సిలిండర్. ఆర్ ఏబుల్ టు అండర్స్టాండ్ నా? ఇఫ్ ఐ లుక్ ఫ్రమ్ దిస్ సైడ్, ఇలాగే కదా నాకు కనిపించేది. సో ఐ హ్యావ్ రోల్డ్ దిస్ కార్పెట్ లైక్ దిస్. What is the initial mass of the carpet? Mass of the carpet is m, and it is made up of inextensible material. So it became a cylinder whose radius is equal to r and is kept on a rough floor. It means there is no slipping. Okay, ma? The carpet starts unrolling, okay, without sliding on the floor when a small push is given. So it is present on a ground. I have given a small jerk to this one. Okay, small push means what? This external force you can consider 0. Very small force. Then it started unrolling. Unroll avutundi kada carpet, so it started unrolling. So you are supposed to calculate what is the horizontal velocity of axis of the cylinder when it reduces to a radius of r by 2. It means that, so initially this is the carpet, so it started unrolling. Then after some time it had become a small cylinder. Unroll avutu unte dan radius taggutu veltundi kada. So its radius has become only how much? Its radius has become r by 2. By this time it will have some velocity, no? It will have some velocity of center of mass. Initially velocity of center of mass was 0, it was in rest position. But when it starts unrolling, then it will gain some velocity. So when it reaches to a radius of r by 2 from r, it will have a velocity of center of mass. So that's what he is asking, no? Calculate the horizontal velocity of axis. Horizontal velocity of axis means what? Velocity of center of mass. So that velocity of center of mass I want to calculate after it has unrolled to a radius of r by 2. Okay, ma? Can you say how can I do the calculation? Based on which logic I can do the calculation? Okay. Anybody? Omega, I don't know. Unroll of the radius తగ్గుతూ వెళ్తుంది కదా. So this is a carpet. It is unrolling. Then it will become like this. No? ఇక్కడ unroll అవుతూ వెళ్తుంది. ఇట్లా ఓపెన్ అవుతూ వెళ్తుంది. When it starts opening, what happens to radius? Size తగ్గుతూ వస్తుంది. This radius I am discussing about. This is the carpet. I am discussing about this radius. Circular radius. That radius continuously decreases. No? So by the time it unrolls to r by 2, I am supposed to calculate what will be the tangential speed. Are you able to understand? See, very easily I can do this problem by using law of conservation of energy. Okay. Already we discussed, no? If you don't find any other method, then always you can go with law of conservation of energy. So on the system, first of all, you should see how many forces are acting. How many forces are present. Why it is unrolling? It is unrolling only because of gravitational force. That's it. Are you able to understand, ma? So because initially center of mass will be present here, no, at a distance of r. Finally center of mass is present here. It is present at a distance of r by 2. So total mass has come down, no, ma? And it is possible only with the help of gravitational force. Are you able to understand? So here only conservative forces are acting. If only conservative forces are acting, then what can I do? I can use law of conservation of mechanical energy I can use. Okay, ma? So because only which forces are acting? Only conservative forces are acting. Okay, ma? Only gravitational force is acting. Other forces are not present. So law of conservation of mechanical energy. What is law of conservation of mechanical energy? K1 plus U1 is equals to K2 plus U2. Okay, ma? Initial kinetic energy is 0, no? Because when it was in rest position, there is no kinetic energy. Initial kinetic energy 0. Initial potential energy. Initial potential energy when it was present of the original shape and size. What is its initial potential energy? mgh. Its total mass is concentrated at center of mass, no? And what is its distance? This distance is r. So mg into r. That is the equation of potential energy, no? So plus mgr or minus mgr. That depends on the reference which you take. I will take ground to be 0 potential energy reference. Ground I am taking to be 0 potential energy reference. When compared to this reference, point is above this 0 potential energy reference, no? So positive potential energy. So plus m into g into r. Okay, ma? Now when it has rolled by r by 2, now when it has reached to r by 2, now it has what kind of kinetic energy can you say? Translational is there or rotational is there? Both are present. It is unrolling, no? Carpet is rolling. That's why he said this is a rough floor. Rough floor means what? The carpet which is in contact with the ground, that is in rest position, because it is a rough floor. So carpet is unrolling. It means it is a rolling body. Rolling body means it will have translational velocity also, rotational velocity also. And total kinetic energy in the last class we studied, no, half mv center of mass square multiplied by 1 plus k square divided by r square. Already we discussed. This is the equation of total kinetic energy, no, for a rolling body. Are you able to understand? And the final potential energy, U2, final potential energy. Potential energy ekkada undi ikkada ippudu. Now mass is present at a distance of only r by 2, no? So m into g into r by 2. mgh, no? H means r by 2 here. But the problem is I have to write m dash into g into r by 2. Why I have written m dash 1? See, previously total mass of the carpet was bigger, but now carpet is only r by 2. No? Carpet's radius is only r by 2, so mass also will be reduced. No? Now m dash value is how much? Anybody can you say? M dash value, how can I calculate? M dash means what? Mass of the carpet when it is of a radius of only r by 2. Now what will be its mass? So in the carpet, mass is distributed in area or mass is distributed in volume. Carpet lo mass ela distribute ayi untundi? Mass is distributed in total volume, no? And what is the volume of a carpet? Volume of a carpet. See, this is how carpet looks like, no? Carpet looks like a cylinder. Okay. So here I have area pi r square. This is area. No? Area multiplied by length. Area means length into breadth. Another dimension is height. Length into breadth into height, volume only. Are you able to understand? So therefore, pi r square into L. Volume of a cylinder is how much, ma? Pi r square into L. That is the volume of a cylinder. Are you able to understand? So substitute. So therefore, how I can write? I will take pi r by 2 whole square into L divided by pi r square into L multiplied by capital M. I can write like this. So this is the volume of final cylinder. Radius is only r by 2, no? But length is same. Okay, no? This length remains same, no? Similarly, what is the volume of initial cylinder? Pi r square into L. So if you take the fraction of this, what you called volumes, you will get fractional volume. Fraction multiplied by total mass, fractional mass. Technique of calculating the mass of the remaining cylinder. Okay, ma? So everything gets cancelled. I will get m by 4. M by 4 only I will get, no? Pi r square, L, everything gets cancelled. 1 by 2 whole square is 4. M by 4 I will get. So what is this m by 4? This is the mass of final cylinder. Are you able to understand? So substitute that value there. So therefore substituting mgr is equals to half m v center of mass square multiplied by 1 plus. Now what is k square by r square value for a cylinder? Cylinder. This is a hollow cylinder or solid cylinder? Solid cylinder. ఎక్కడ ఉంటుంది కార్పెట్ రోల్ చేస్తే స్పేస్ ఎక్కడ ఉంటుంది మీకు? If you roll a carpet, it becomes a solid cylinder. Hollow cylinder ఎట్లా అవుతుంది అది? It becomes a solid cylinder. Solid cylinder moment of inertia is equal to moment of inertia of a disc, no? Moment of inertia of a disc, half m r square. Moment of inertia of a solid cylinder also, half m r square. Are you able to understand? So k square by r square value is how much? 1 by 2. Okay. Already we discussed, no? K square by r square value denotes shape of a body, type of body. So k square by r square value for a disc is 1 by 2. For a cylinder also, solid cylinder also, 1 by 2. Okay, ma? So plus m dash. M dash is how much? M by 4 multiplied by g multiplied by r by 2. This is my final answer. So from this what I am supposed to find out? Just VCM. So calculate that VCM. That is my required answer. Understood, Nama? That's it. So final answer I will write down. Check whether you get the same answer or not. So answer is root 14 gr by 3. So root 14 gr divided by 3. That is the final answer which you should get. So have you understood now the methods of calculation? So to do problems of physics, your previous knowledge also is very, very important. So that is why okay, ma? So see this question. See, ma, this is a hemispherical cup. So hemispherical cup. What is meant by hemispherical cup, ma? Cup made up of half of the sphere, hollow sphere, hollow sphere. So from the top of this cup, we are releasing one solid sphere. Mass of the solid sphere is m. Okay. Then it starts rolling down and it is reaching to the bottom of this, what you call this hemispherical cup. By the time it reaches to the bottom, its velocity cannot be zero, it will have some velocity. So how much velocity we don't know. So let that velocity be some v. We don't know what is that velocity. Are you able to understand? Then by the time it comes to the base of this hemisphere, we are supposed to find out what is the normal reaction that is acting on this solid sphere because of the hemispherical cup that I want to calculate. Okay? Can you say? How can I do this calculation? How can I calculate normal reaction on this solid sphere because of the hemispherical cup? How can I calculate? Seema. So let us consider when it is present at the base of this cup, its weight mg will be acting in downwards direction. No? Weight of this what you call sphere, it will be acting in downward direction. And cup will give certain normal reaction. Cup oka normal reaction istundi kada. In this condition, can I say n is equal to mg? Normal reaction and mg, are they equal? Equal. They are not equal. Why they are not equal? N and mg will be equal only when body is moving in a straight line. But here body is moving in a circular path. Body is moving hemispherical cup. This is example of a circle. Clear now? So this sphere, it is moving in a circular path. Circular path means definitely body should have some centripetal force. No? Without a centripetal force, any body cannot move in a circular path. So who is providing centripetal force here? Centripetal force ni provide chestunnadi evaru? The difference of these two must be providing. Various forces available kada. That only two forces which are acting is one is normal reaction, another one is weight mg. So centripetal force should be towards which direction? Towards the center of the circle. This is the central circular path. So centripetal force should be acting towards the center of the circle. It is possible only when normal reaction is greater than mg. Already we studied in circular motion, again we are studying. Only when normal reaction is greater than mg, then only there will be some net force acting towards the center of the circle. Are you able to understand now? Okay. So therefore what I can write, n minus mg becomes the net force, no? Because n is greater than mg, n minus mg will become the net force. And what this net force is doing? This is providing the centripetal force. And formula of centripetal force is mv square divided by r. Okay, ma? So therefore what is n value? N value is mv square by r plus mg. Are you able to understand? So if I do this calculation, then I will get the normal reaction acting on that sphere because of the hemisphere, because of the cup. Okay. But the problem is velocity, is it given? Ma? Velocity is not given. This is our assumed value. This value I don't know. So the question is, how can I calculate velocity? Velocity was there, I can do the calculation. I can substitute in this equation and I can get the answer. Are you able to understand? Whenever body is moving in a circular path, definitely you should remember that centripetal force will be acting. Are you able to understand? Ma? And centripetal force can be provided by that force which is acting towards the center of the circle. Now the question is, how can I find out the velocity by the time it reaches the bottom of the cup? ఎలా చేస్తాం? అదే కదా మనం డిస్కస్ చేసుకుంది. We have to use law of conservation of energy. Are you able to understand? Ma? See, ma, this sphere is rolling down because of which force? కిందికి ఎందుకు వస్తుంది? Only because of gravitational force, no? And gravitational force is what kind of force? Conservative force. Clear, no? So sphere comes down by which force? By gravitational force. And it is what kind of force? It is a conservative force. Are you able to understand? So because this is conservative force, I can use the law of conservation of mechanical energy. Law of conservation of mechanical energy. What is law of conservation of mechanical energy? K1 plus U1 is equals to K2 plus U2. Okay, ma? So what is the initial kinetic energy? Initial kinetic energy of the system. Ball ni release చేసినప్పుడు, when I release the ball, is it having any kinetic energy? రిలీజ్ చేసిన వెంటనే kinetic energy ఉంటుందా? పుడతానే పెళ్లి చేస్తాం ఎవరికన్నా, చేయం కదా. రిలీజ్ చేస్తూనే it doesn't have any velocity. So initial kinetic energy is 0. Initial potential energy of the ball, that depends on the reference. Potential energy you can never define without a reference. Are you able to understand, ma? Which one shall I take? I will take this one to be my reference of zero potential energy reference. Understood, ma? So therefore, when compared to this position, now this one is present at a height of r, no ma? ఇక్కడ నుంచి ఇక్కడ వరకు రేడియస్ అవుతుంది కదా. So this height is nothing but radius. So initial potential energy is mgh. Instead of h I can write r, mgr plus mgr only, no? Why? Because the ball is above the reference. If it is above the reference, potential energy should be taken positive. Clear, no? So this is equal to final kinetic energy, half abba. Final kinetic energy is how much? Is it a point mass? Sphere point mass, కాదు కదా, రోల్ అవుతూ కిందికి వస్తుంది. Because it is rolling, it will have both rotational kinetic energy as well as translational kinetic energy. రెండు kinetic energies ఉంటాయి. So therefore, what is the total kinetic energy? Yesterday we have written to half mv center of mass square multiplied by 1 plus k square divided by r square. This is the formula. ఇదే కదా నిన్న మనం డిరైవ్ చేసింది. This is the total kinetic energy, which is the sum of translational as well as rotational. Clear, no? Plus final potential energy. Final potential energy. Now body has reached to zero potential energy reference, no? So final potential energy will be 0. Are you able to understand? That's all. So now what is k square by r square value for a solid sphere? 2 by 5. This is the k square by r square value for a solid sphere. Are you able to understand, ma? Now substitute all those values, then you will get velocity of center of mass. Are you able to understand, ma? So take that velocity of center of mass and you substitute here. Are you able to understand, ma? Then I will get the required normal reaction. That's all. That is my answer. అర్థమైంది ఎలా చేసాము? So first I have written equation for centripetal force. Then I have used a law of conservation of energy, calculated velocity. Once I calculate velocity, I can get the normal reaction. That is the process of solving. Clear? Come on. Okay, ma? So when you substitute velocity of center of mass here, the final answer which you should get is 17 by 7 mg. So check whether you get this answer or not. Clear, ma? That's it. Okay, now see. So see this question. So this is an inclined plane, ma, which is present like this, and on that inclined plane there is a hollow sphere which is moving with a velocity of v. Are you able to understand? And angular velocity is also given omega. Then we are supposed to find out what is the maximum height that this sphere can obtain on this inclined plane. See, ma, by the time it starts moving, gravitational force will be pulling it downwards, no? So what happens to the speed of this particle? Speed continuously reduces, and after reaching some maximum height, its velocity will become 0. So at that position, I want to calculate what is the maximum height that this particle can reach. Okay? Anybody? How can I do? Come on. How can I do this calculation? How many forces are acting, ma? Only gravitational force is acting. So therefore, I can use law of conservation of mechanical energy. That's all. Initial kinetic energy. Which energy? Translational energy or rotational energy? రెండు ఉన్నాయి కదయ్యా. It is moving also in a straight line. It is rotating also. So two energies are there, no? So therefore, what is the total kinetic energy? Half m v center of mass square multiplied by 1 plus k square divided by r square. This is the total kinetic energy, sum of kinetic energy of translation, kinetic energy of rotation. Initial potential energy, I will take this one to be my reference, 0 potential energy reference. Therefore, what is initial potential energy? 0. Clear now? So this is equals to final kinetic energy. So this hollow sphere, after some time, let us consider it reached up to here. Up to which height? Up to a height of h. Okay? So this is maximum height. No? After reaching to maximum height, what will be its velocity? 0. Final velocity will be 0. So translational velocity is 0 or rotational velocity is 0? Both are 0. No? So both kinetic energies are 0. Okay? Final potential energy, mgh. So mgh max plus mgh only, no, because it is above the reference. Now just this h value I am supposed to calculate. Height only, no, he is asking. H max, no, substitute the value. So what is k square by r square value for a hollow sphere, ma? For a hollow sphere it is 2 by 3. Clear? So substitute all the values. Mass is how much? Mass, did he give anything? Mass is not given. No need of mass also. So half m v center of mass square multiplied by 1 plus k square by r square value 2 by 3 is equals to mgh max. Clear now? So mass and mass gets cancelled. So half v square 5 by 2, 5 by 3 is equals to g into h max. Okay? So therefore h max is equal to how much, ma? So 5 by 6 v square divided by g. So this is the maximum height this particle can reach. That's it. Okay?